Good morning, ladies and gentlemen. Today what we're looking at is index laws, and essentially it'll just be a recap from Year 9. So the laws are listed on the left. There's 5 of them, along with the zero power law. And I'm just going to go through 3 very quick examples to show applying the laws. Now, you'll note, to start off with, none of the laws here involve adding or subtracting 2 bases. So for example, if you have something like this, a to the 7 plus a to the 6, it might be very tempting to write a to the 13, but you can't do anything. That's as simple as it gets. And for that reason, many of the questions you'll see will involve multiplying and dividing because they can apply the laws. So just keep that in mind, that if you do see a plus there are none of the laws apply to it and you can't simplify it any further. Alright, our first example, simplify. Generally, work on the top and work on the bottom and then try and cancel them out. So on the top here, order doesn't really matter because it's all multiplied. 4 times 4 is 4 squared, or 16, and I'll write it as 16 because that'll become useful in a second. N to the 7. The powers add over 16. The 16s cancel. When you're cancelling, just think about a 1 going there and a 1 going there. Dividing by 1, we typically don't write, so we just ignore the bottom from now on, and it's n to the 7. All right. Next example. A little more complex. Try to deal with things inside the brackets first if there's a chance of making it simpler that way. So for example here, with t9 over t7, that is really the same as t to the 2. And this here, power raised to another power multiplies, so it's t to the 30. Or t to the 30 divided by t to the 6. Now, as long as you know your rules, these just drop out nice and comfortably. Note that if we divide the bases, we're not actually dividing the powers. Don't write here t to the 5. You should be writing t to the 24, because we subtract the powers. 30 takes 6. Alright. Last example, record video. When there are powers outside, make sure they apply both and everything on the inside. Alright. So 2 to the 2, m to the 6 over. Now here's the interesting thing. If 0 goes in there, it makes the entire thing 1. So it's over 3 multiplied by 6 squared n to the 10 over. Now minus 2 to the power of 3 is minus 2 times minus 2 times minus 2 is minus 8. Alright. If you type in your calculator literally this minus 2 hat 3, it will give you minus 8. But if you type in, which is correct, minus 2 hat 2, it'll give you minus 4, when in fact you might mean this, which should be positive 4. So be mindful that when you have odd powers above a negative, you'll come up with an odd. If you a negative rather. If you have even powers above a negative, like that, it should come out as positive. Alright. So that's minus 8 n to the 3 m to the 4. Alright. Now, this multiply here really turns this into one gigantic fraction. We can almost think of this as, as one line across here with a little times on top and a times on the bottom, like that. What I'm saying is that you can cancel across, so the m6 and m4 can cancel out. 2 to the 2, m to the 2, times 6 squared n7. These two have cancelled out, 3 up there and 4 m's here, and on the bottom we're left with, well, a 3 times neg 8. Alright, so letters are as simple as they can get. Now dealing with the numbers, and you'll expect to do this in your head relatively quickly. A couple of different ways to go about this. One way is to break things down a little. So for example, 2 to the 2, I'd think of that as, well, 2 times 2, m squared, times 6 times 6, but we're not going to throw out many 6's on the bottom, so I might go 3 times 2 times 6. n to the 7 over 3 times -2 times 4. Well, 4 might be another 2 and another 2. Alright. Now, that's 3 2's. 3 2's go. Remember, that stays as a -1. That 3 and that 3 go. What we're left with is 6 on the top, m squared n to the 7 over -1. Now, that -1, we would normally just write towards the top, because dividing by -1 is the same as multiplying the top by -1. And that would be our answer. Alright, thank you very much for listening. We will go through plenty of practice of these. I find them quite satisfying because you can take a mess like that and watch it drop out to something relatively simple. Alright, thank you very much.